Hello, it's me. And I was wondering if after all these hours you'd like to meet, to go over everything. Take a look at input and output tables and determine if it's properly functioning. Hello. Anyways, happy Thursday, my friends. What we want to do is I want to recap a little bit of yesterday. You dealt with a soda machine where if I pushed for the slurp, I should get slurp. If I pushed for the blast, I should get the blast. But if I push a slurp and get a blast out, that's not how it should work, should it? No. See, when you go to get a vending machine or when you go through the McDonald's drive-thru to order something, you expect to get what you paid for, right? So when I give you a function or a rule, there are specific outputs that you should get for each input. So what we tried to do is take a look at how to determine if a table of inputs and outputs is a function or not based off of looking at those inputs and outputs. So here's the deal. Let's take a look at our list of inputs. Are they all different? They are. So all the inputs that are in the table are completely different. Let's take a look at our outputs then. -3 to 9, -2 to 4, -1 to 1, 0 to 0, 1, 1, 2, 4, 3, 9. Okay, so these two inputs are the same. Are those outputs, I'm sorry. And so are these outputs. So I've got some inputs with similar outputs. That's kind of weird. That's not right. But why don't we go ahead and take a look at the graph? If we take a look at the graph of all of these points, we see that we have a quadratic, right? We've got a parabola. As I move from left to right, not one singular time would I cross more than one point for one output. See, my inputs can share outputs, but my outputs cannot share inputs. Let me show you what I'm talking about. If we take a look here, all the same x inputs are in my little x pool, same with the y's. Now our function is our rule that maps our x values to our y values. I put my x values into the machine and I get the y values out. So, when I get -3, plug in -3, I get 9. If I plug in -2, I get 4. When I plug in -1, I get 1. If I plug in 0, I get 0. But here's the part where it gets a little tricky. When I plug in 1, I get 1. When I plug in 2, I get 4. And when I plug in 3, I get 9. But this is what it is. Every x value, every input has exactly one output. So -3 only has one output, just one output. But it's okay for there to be outputs that have a couple of inputs. We just saw, this is a quadratic function. It's a parabola. So as we go around, you got 1, 4, 9, and so on and so forth. So it is okay for the inputs to have common outputs. But what should never happen is that we have one input that has two different outputs. Let me show you what I mean. So we take a look. I've got this table of values. -3, -2, -1, 0, +1, -2, -3, and all my outputs. You see I have a couple of repeated inputs. Strange. Very, very strange. Let's take a look. Let's map them. So I've got my x's, my pool of x values that are in the table. See, -2 is there twice, same with -3. Then I've got my y values. I got my pool of y values. -3 maps to 6. Okay. -2 maps to 4. All right. -1 maps to -1. That's cool with me. 0 maps to 0. We're doing cool. We're fine. But then 1, maps to -1. That's cool. Remember what I said last time? Inputs can share a common output. That's all right. That's okay. But then we map negative 2 to 2. What? And negative 3 to 3. What? That just doesn't make sense to me. See, negative 3 is getting mapped to 2 different numbers. So you got same input, but 2 different outputs. And that can't happen at all. So this would not be a function. So the things to look at, pals, the things to ask yourself, are your inputs repeated? If so, do they share the same output or do they have different outputs? And that's how you can tell. Is it a function or is it not a function? Because if we take a look at a graph for this, I tell you what, I'm going from negative 3 to negative 2 to negative 1 to 0 to 1, back to negative 2. When you draw a graph, you're going all the way across. Not once am I going to swirl backwards. If you're graphing a circle or an ellipse or something like that, that's different. That's different. Those are equations. Those are formulas. Those are not functions. But when you are graphing a function, you should never, ever, ever, ever go backwards. Now you can squiggle up and down. You can move that pencil all around. But you cannot go backwards. That would not be a function. I hope this helps.